For this example, they're wanting us to find the area of the region enclosed by the graphs y equals 0, y equals 2 over x equals c, and x equals 1. So this problem really does require you to have a very good working knowledge of what these graphs look like. This is a calculator not allowed section, so you're not going to be able to graph those. So when you go to do this right now, you got to be able to kind of pull from memory. So y equals 0, that's actually just going to be our x-axis right here. So that's just the bottom of the graph, that's our x-axis. Y equals 2 over x, that graph looks something like this. So anything, a number over x is going to be this sort of shape of graph. And the reason that I'm only worried about the first quadrant here is because when we're looking for this c value that they're going to be talking to us about, c has to live between 0 and 1. So I know it has to be somewhere between here and here. And then they tell me that x equals 1, which is going to be a vertical line, that closes this region off. And from there, what they want us to do is sort of find out what is that area. So you have in here C, right? C isn't a number, and so how do I know where exactly to position C? That's where this first piece comes into play. They're telling us that C has to live between 0 and 1. Since 1 is our endpoint out here, we know C has to be some other value back here. It doesn't really matter where, but you just kind of want to give yourself that little sort of picture to work from. Now, what they're asking you to find is going to be this region here. So what this will end up being is a definite integral. Even though we're talking about the region enclosed by the graphs, which is very often trying to find the area between two graphs, because y equals 0 is our other graph, we just get to treat this like a normal definite integral. So if I was going to set this definite integral up, reminding myself that this is the graph of 2 over x and I want the area below that, I would do the antiderivative starting at c, my lower bound, and ending at 1, my upper bound, of 2 over x dx. Going to find the antiderivative of that, 2 over x, that is what I refer to as a special case antiderivative. There are certain antiderivatives you just have to have memorized, and this is one of them. So anytime you have the situation where you've got a number over x to just the first power, that's the only time this happens, then out of there what you're going to get is you're going to get whatever that number is on top times the natural log of x plus c. So here, looking at this problem, our a value that we talk about, that's going to be 2. So this would be 2 times the natural log of x. And because we have bounds, we would say evaluated from x equals c to x equals 1. Now from there, once you're going to evaluate that, this is when I do what I just call my top minus bottom move. So we're going to come in, and the way we evaluate this is we take the top value, plug it into our equation, and subtract off the bottom value plugged into the equation. So out of there, we would get 2 times the natural log of 1 minus 2 times the natural log of c. And from here, we have to start trying to simplify it down because you look up top and your answer isn't there. And so this is where some algebra skills start coming in and some general knowledge of what these things look like. The natural log of 1, that is 0. Because if you were thinking about this, the natural log is log base e. And so you're saying e to what power would equal 1. That's how you would solve that. So anytime you take the log of 1, no matter if it's a natural log, log base 10, the answer is always 0. So on the right-hand side, we have 2 times 0, which is going to just leave us with 0. Then from there, if I just kind of simplify that, so I know that the front zeroed out, so that's all gone. So this is now 2 times the natural log of c. Here's where some laws of exponents comes in. So this is really pulling from a lot of different ideas. Laws of logarithms, not laws of exponents. It'll be laws of exponents in a second, but right now it starts off as a laws of logarithms. So one of our laws of logarithms says if I have a number being multiplied in front of my log, then I can rewrite that by bringing that power up to the top. So I can pull that number up in front and make it a power on that x on the inside. And that's what you're going to do here. You're going to pull this -2 up and make it a power on that c value. So this is going to be the natural log of c to the -2. Now we get into that laws of exponents game. This is when we would be looking at a rewrite. We learned how to do this rewrite one direction, but we sometimes forget how to undo it. So we had a rule that said when we were doing derivatives and antiderivatives, if I have x underneath on the bottom of a fraction, I used to always want to pull it back up to the top and make that power negative, because then I could do a power rule on it, whether I'm doing a derivative or an antiderivative. And so if you had something like 5 over x to the third, you'd want to rewrite that as 5x to the -3. Well, where we're at right now is we're actually on this side of the problem. We've got something raised to a negative power. And so what we want to do is undo that rewrite. We want to put that power back down to the bottom and make it positive. So undoing that rewrite right now, I'd still have a 1 left on top because there's really an unwritten 1 right there, just like there's a 5 right here. And then I would push that back down to the bottom and make that c squared positive. And so that would be my final answer. And that's going to look like option C. So this problem brought in a lot of pieces that this is kind of one of those questions that I talk to people about. This differentiates you between getting a 3 on the test and getting a 4 or 5 on the test, because you needed to know how to graph these equations. You needed to know your antiderivative, your definite integrals, what gives you the area between the curve and the x-axis. You had to know the special case for natural log. You had to know that the natural log of 1 was equal to 0, and then you had to rock some laws of logs and some rewrites, some laws of exponents to get that into the final form that they were looking for their answers. So this is definitely the ones that separate those from who get the 3s from those who get the 4 and the 5. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.